Hello, you are welcome to Motion Study in SolidWorks. We'll be looking at a connecting rod slider mechanism. Um, the motion study of the mechanism will be done with a linear motor of the following properties: an oscillating amplitude of 450 millimeters, a frequency of 1 hertz, and phase angle of 2 degrees. Now, the key objectives will be to investigate the variation of some key parameters such as piston displacement, velocity and acceleration, reactive force of the connecting rod, frictional force between piston and walls, etc. Probably, or you can also carry out a dynamic stress simulation of the system to observe the variation of formic stress for the time duration. But we'll be looking at the first point in our video, and let's see how we can extract key parameters such as displacement, velocity and acceleration of the piston and also other components. So we have the model here, and we need to carry out a motion study. If you don't have a motion study here, you can right click on the motion study. I have an existing motion study. Just right click on motion study and create a new motion study. I can disable orientation and camera views. Can disable that so that it does not mess up our view. Now, the first thing you will need to do, or what you need to do really, is to ensure that you have motion analysis right here. If that is not there, what you can do is to go to tools, and under tools you go to add-ins and ensure that SolidWorks motion is checked here, right here. So we have it checked for us here, and we'll be selecting motion analysis. Now, for motion analysis, in this toolbar, you'll be walking or moving from right to left. So we'll apply gravity first, and gravity will be in the negative direction of y. Then we'll also do a contact set to ensure that SolidWorks takes note of motion or contact between pairs of components. So we have solid bodies. We can just create a window like this, and when you have done that, you okay that there. Next thing, we can decide to apply a force or a damper or a spring, but we don't have any of that as our condition. So we select a motor. Remember, we're asked to apply a linear motor with an oscillating amplitude of 450 millimeters, frequency of 1 hertz, and 2-degree phase angle. So we'll select a linear motor, and the direction we are going to be moving this. Yes, we'll select that face. So the direction will be opposite the direction that we have there. So we'll just click on that to get the opposite direction, and then we'll be selecting oscillating amplitude, and change this to 450 millimeters, 1 hertz, and phase angle of 2 degrees. So we have that all set up. We can decide to click the graph, and we see that there, this is the motion the piston will be undertaking. So we click on that, and then we are good to run our model or simulation. Now, to run the motion study, you will need to click on this button to calculate the motion study. So SolidWorks has to calculate each time instant of the motion study. So you click on that, and you have that. So SolidWorks has calculated 5 seconds. This is 0, this is 2, this is 4, and this is 5 seconds of this the animation or study or the motion. Now we can decide to take this to 3 seconds or 4 seconds, whatever the case will be, and we can recalculate that for 4 seconds. Yes. So the next thing will be to extract our results. And to extract our results, you just click on this button, and the first thing is displacement. We can trace the paths. We can decide to trace the path of a point on the connecting rod. So we can simply select that, and you see the path that point takes. That's the point. That's the path that point makes as the system is in motion. The next is to get the velocity of the velocity linear velocity of the piston, the second piston. So magnitude, you can read that. You just highlight that and you read select one face, one vertex, or one path. So we can select a face, select this face, and then we have that. So you can observe the motion or the plot of the velocity as the piston, the second piston moves in that slot. We can close that and select a new result. This time we'll be selecting the acceleration of the second piston, linear acceleration, the magnitude. We select the face and we okay that, and we have the acceleration of that piston. We can select or investigate the energy, say kinetic energy of the second piston. We have that, and we have a result as this. Now you can go further to do some stress analysis at different several time instance. We will not be doing that in this video. So this is all. There are other settings one can do. There's so many things you can do. If you have a crank, in the case of a crank you will need a rotary motor, and then so many other things you can do with motion analysis. I think that's all we have for now. Thank you.